Hey guys, the weather outside sucks right now, so instead of going out and enjoying the great outdoors, I thought I'd sit down, turn on my favorite video game console, throw a couple virtual baseballs, take a couple digital swings. Now, no matter how good the graphics are or how good the gameplay is, it's just not quite the real thing. Now, for those of you who don't know or haven't read the blog on Edacity.ca this month, baseball is kind of my thing. I played a lot growing up, and even a little college baseball down here in Lethbridge. And I can honestly say it's a lot harder than it looks. One thing that makes baseball so difficult is actually hitting the baseball. Pitchers in the major leagues can reach speeds up to 100 miles an hour, but that's not the only trick they have up their sleeves. Throwing a ball at seemingly superhuman speed is one thing, but they also utilize different pitch types, like curveballs, that just don't fly straight. Something like this. So how does this happen? Well, it has to do with the rotation of the ball when the pitcher lets it go. And to understand why that matters, we need to talk a little bit about aerodynamics. Let's take a closer look at what's happening here. Our pitcher throws a fastball at our hitter. And a fastball has backspin, like this. Now, as the air flows around the baseball, the ball encounters a whole lot of air resistance, and the rotation of the baseball plays a huge part in what happens while it's moving. With a fastball, the bottom of the baseball is rotating in a direction against airflow, while the top of the ball is rotating in a direction with airflow. This causes a difference in air pressure around the baseball, with an area of high pressure under the ball and an area of low pressure above the ball. This gives the ball just a little bit of lift, which keeps it on a relatively straight and consistent path. Now, a curveball is kind of like an anti-fastball. Instead of being thrown with backspin, a curveball is thrown with topspin, like this. This reverses the rotation of the baseball and causes the areas of high and low pressure around the baseball to switch places. Now the area of high pressure is on top of the baseball, pushing it down. This causes the ball to drop or curve faster than it normally would. You guys really need to work on your tan. Now, I know what you're probably thinking. Jeff, why do I care about why a curveball curves? Well, this difference in high and low air pressure is the reason why an airplane can fly, or what causes changes in weather patterns, or something even as simple as why that soda you're drinking is going up that straw. It's a little bit of physics that goes a long way, and that's science. I don't know about you guys, but I like finding out about how the world works. So, if you have a question about how something works, why something works, let us know. Comment on Facebook or shoot us a tweet on Twitter, and we'll post a video answering your questions. So go. What are you waiting for? Go.